just to build some intuition for like what we're dealing with. You have a object that's like, let's say you have some UAP that's like 50,000 feet away from you, and is traveling at like 6,000, 7,000, miles per hour. First of all, we're not going to see it with the naked eye 50,000 feet away unless it wants to be seen, in my opinion. So look, let's assume it doesn't want to be seen, and we're still trying to track these things. Like, we're still trying to find them. That's the whole point, right? Is to outsmart at least some of these things at least some of the time. That's the game. And so in those cases, they will often show up in infrared. This is just like, right, just the intuition for like the fact that just based off the fact that all objects give off heat. So, if you're looking for like heat or some kind of heat signature, that would be the general thinking. Anyways, what the problem is that as you go deeper and deeper into the infrared wavelength and spectrum, the farther this object is, the more fainter it's going to be, and generally speaking, the harder the resolution will be to resolve. And so what ends up happening is this sort of like perfect storm, if you will. So the object is faint, it's in the background, your camera sees it, and you're trying to lock onto it and keep like detecting it and clearly differentiate it between other objects. So not an easy problem, but it is solvable. And it is also, very, very useful in general for other cases, scientific applications like, asteroid detection in space, right? For example. So all that is to say, that was category 2 and 3 of problems that were sort of subsets of this propulsion track that we had, where once you've detected the object, how do you then essentially triangulate these things, right? So, first of all, there's a whole bunch of different kinds of data that you're going to be getting. There's passive radar data and there's active radar data that you can tap into with UAP detection. Passive radar, is essentially, I'm going to exploit the fact that there's radio frequencies sort of, seeming out into the world everywhere from these radio towers and so on and so forth. And as those radio waves, bounce off of planes and bounce off of UAPs, right? I'll detect those waves. So it's kind of like being very cheeky in the sense that you're taking leverage of the fact that we're bathed in electromagnetic radiation. So why not leverage that fact and detect reflected electromagnetic radiation across the entire